Hello everyone, welcome back again. Here in this video, we are going to design a sediment excluder. Okay, before this video, we have already done on one numerical related to the designing of silt excluder. You can see here, this numerical is already done in previous video, and this question is taken from the world question, and this question is asked in Pokhara University 2018 fall. Okay, and related to this topic, in this video we are going to design a sediment excluder. Okay, and you can see here, this is the question taken, and this question is also asked in Pokhara University. Okay, so we are going to solve this numerical, and this numerical is designing of sedimented excluder. Okay, so let's see the solution. And if you are new to the channel, please do subscribe the channel, like the video, and press the bell icon so you will get regular updates. Okay, and I have uploaded different numericals related to our irrigation engineering as well our civil engineering. Okay, so you can visit our channel. Okay, and let's see the question first. Design a sediment excluder is to be designed for a canal head of taking from a river with a dominant discharge of 800 cubic. Okay, we have given discharge is 8000 cubic. The order data of a canal excluder, and these all data are given for the designing of sediment excluder. Canal discharge is given 284 cubic, width of under sluice span of a barrage where canal regulator is to be provided with an excluder equal to 15.35 meter. River excluder is given 15.35 meter. River bed slope equal to 1 by 4000. Average sediment diameter 0.37 meter. Head available 0.8 meter, and the meaning rigidity coefficient is given 0.06. Okay, so these all parameters are given for designing of sediment excluder. Okay, now we have to design. So let's see the solution. As we already discussed in previous video, we have to take 20% of the canal design discharge. Okay, for the discharge of sediment excluder. Okay, so design discharge of a silt excluder is taken 20% of a canal discharge. Okay, it means 0.2 into, we have to take the canal design discharge, and this is given in the question 284. Okay, so we have to just multiply 0.2 into 284. This means 20% of canal discharge. Okay, so after calculating, we get design discharge for the silt excluder equal to 56.80 meter cube per second. Okay, now we have to design a tunnel. Okay, for the silt excluder, we have to design a tunnel. In very first step, we have to assume the number of tunnels that we are going to provide for the sediment excluder. Okay, so let us assume in this numerical we are going to provide a number of tunnel equal to 6. Okay, so let us provide 6 number of tunnel, and in second step we have to calculate the width of tunnel. Okay, width of tunnel at the exit. Okay, for the width of tunnel we have to assume the value of a divide wall. Okay, and the value of divide wall is generally taken 0.6 meter, as we discussed in previous video also. Okay, you can see here we have taken okay, you can see here thickness of divide wall is generally taken 0.60 meter. Okay, so 0.6 meter width of divide wall. Then the width of tunnel at exit equal to 15.35 minus 5 into 0.6. Okay, and you can see this value is taken, and for the width of tunnel at exit, we have to minus this width of divide wall. Okay, so for this we simply we have to divide this divide wall, and as we already discussed, we are going to provide 6 number of tunnel. Okay, that's why we have to minus this width into this number of tunnel. Okay, so we have to minus this value width of divide wall. We have to total calculate total width of divide wall. Okay, for the this total width of divide wall is taken 5 into 0.6. Why we multiply this? Because whenever we take 6 number of tunnels, okay, the total width of divide wall becomes 5 times of 0.6. Okay, so we have to minus this value from the river bed of slope. Okay, this is the river bed of slope, river bed slope minus 5 times of 0.6. Okay, so river bed of slope is given in the question. You can see here the river bed of sorry, this is the river excluder. Okay, river excluder. Okay, so the value of river excluder is given in the question 15.35. Okay, so we have to just minus this width of divide wall from the river excluder. So the river excluder is given 15.35 meter minus 5 times of width of divide wall. Okay, so this value becomes, and for the single one tunnel we have to also divide this value with number of tunnel, that is 6. After calculating this value we get 2.06 meter. Okay, that is the width of tunnel at exit. Okay, okay, now in third step we have to calculate discharge through one tunnel. Okay, so we have calculated total discharge for the silt excluder is 56.80, and now we have to calculate discharge for a single tunnel. Okay, and whenever we calculate a discharge for a single tunnel, we have to divide the number of tunnel. Okay, that is a 6 for this value. Okay, we have total discharge is 56.8 and the total number of tunnel is 6. So we have to divide with the total number of tunnel for getting a discharge of single tunnel. Then the value of discharge becomes 9.47 meter cube per second for the single tunnel. Okay, now in fourth step, the height of tunnel is chosen such that velocity through it is in order to 2 meter or more. We have to take the height of tunnel, okay, according to the such that the velocity through it is in order to 2 meter or more than 2 meter. Okay, for this let us assume exit velocity is taken higher. Okay, that is the higher of 2 meter per second. Then we have to say, let us assume the exit velocity is 3 meter, or you can say you can take the value higher than 2 meter. Okay, 2.53 and whatever you want. Okay, so let us assume 3 meter per second. Now we have to calculate the area of tunnel at exit. Okay, and we have already the velocity is 3 meter and discharge is also you can see here 9.47 for a single tunnel. Okay, now we can calculate the exit sorry, we have to calculate the area of tunnel. Okay, for the area of tunnel we can simply use area equal to Q by V, as we know. Okay, and we will use this formula in so many times. So the discharge that we have calculated for a single tunnel is 9.47 and the velocity we taken is 3. Okay, then the area is becomes 3.16 meter square. Okay, and whenever the area becomes and the thickness is also known, that is 2.06 meter. Okay, width of tunnel is already known. Okay, and whenever the area and the width is known, you can see here area equal to width into height. Okay, with the help of this formula we can simply calculate value of h, and the value of h is calculated area by width. Okay, and area is already calculated, that is the 3.16, and we have to divide this value with width. Okay, and we already calculate the width of tunnel is at exit is 0.6. Okay, after calculating this value we get the value of height equal to 1.53 meter. Okay, that's why provide height of tunnel at exit equal to 1.53 meter, and this is provided throughout the tunnel length. Okay, so this is the height of tunnel at the exit, that is 1.53 meter. Okay, in now in 5th step, in 5th step we have to calculate the width of tunnel. Okay, at infinity. For this let us assume velocity at infinity equal to 2 meter. Then we can calculate the area equal to q by v. Q is already calculated, that is discharge for a single tunnel is 9.47 by velocity is taken if 2 meter, then the area becomes 4.74 meter square. Okay, and tunnel width at infinity equal to 4.74 area by we have to as we calculated in this previous. Okay, b area by we have to divide by 1.53. Okay, that is the height. Okay, as we calculated h equal to 1.53. Okay, then this value becomes 3.09, and this is nearly equal to 3.10 meter. Now we have to calculate for better smooth intensity width of tunnel equal to 2 times of exit width. So 2 into exit width we already calculated, that is 2.06 meter. Okay, you can see here we have calculated width of exit tunnel at exit equal to 2.06 meter. Okay, so this value becomes 4.12 meter. Okay, so we have calculated different parameter for the tunnel as well discharge for the silt excluder. Okay, in this way you can calculate the sediment excluder. Okay, hope you guys are understand well. Thank you very much. See you in next video. If you have any queries, please comment down below. Thank you very much, and don't forget to like, share and subscribe the channel. Thank you. And also in next video we will gonna solve this numerical. Okay, and this numerical is also similar to previous numerical. Okay, so if you see this numerical, you can easily determine different design of different problems related to designing of silt excluder. Okay, thank you very much. Please do like, share and subscribe the channel. Thank you.